let's get started. Every day, people are on the move, whether jet-setting across the continents or racing through the ranks or savoring their unforgettable experiences. But out of all this, every financial institutions have one common mission, that is to ensure that your funds flow in the right directions, slowly, safely, and smoothly, and ensure that every single transaction checks out, stays compliant, and keeps us all protected. Because the world moves so fast that the right flow of fund and the airtight compliance is crucial. This lets us run without a glitch. This is Bhuvaneshwari Subramani here, Chief Evangelist at Intuitive.ai, AWS Hero and AWS Ambassador, joining hands with two amazing machine learning heroes, INR J. Krishnan and Vivek Raja PS from AWS India community, joining here to talk about AWS Strands Power. That is, we are going to talk about the use case anti-money laundering, multi-agent orchestration with AWS Strands. And this will propel you to help the financial institutions maintain compliance with confidence. That's what we are going to see today. So we'll be focusing on the global impact of anti-money laundering and the evolving compliance. We're going to see how the agentic AI workflow implemented using AWS Strands is going to solve this problem against the financial crime. And we will also take you through the demo in detail with a real-life solution. So, financial crime is a global crisis. Around 3.1 trillion illicit funds flowed in 2023, and the similar pattern got repeated in 2024 as well. Where are these funds coming from? Majority of these things, majority of the causes are from drug trafficking, human trafficking, terrorism, and fraud. So all of these things constitutes towards millions of dollars loss. It's a huge financial impact, right? So much of these things goes undetected. That's why we say that anti-money laundering is very, very crucial. So financial organizations like FinCEN have started working on regulations for a quite long time, and no one can solve this alone. That's why we are here to talk about how agentic AI solutions powered by Strands SDK is going to help fight against this. And when we are talking about this, if we go on a little bit of history, I'm not much of a history person, but still, let's take a quick step back and see how the AML standards have evolved. It started with the Bank Secrecy Act in 1970, followed by creation of FATF, which had 40 specific standards as recommendations that the institutions have to follow. And 1992 was the year where suspicion activity report came into existence. That is, if there is any deviation in the financial transaction, the financial organization has to file the suspicious activity report. It could be a real legitimate risk or it could be a potential risk, but it's the duty of the financial institution to file the suspicion activity report. And also it continued to evolve. In 2020 is what we had this Anti-Money Laundering Act that came into picture. So this is the history of how these things evolved. And each milestone have only increased the responsibility and vigilance for the financial institutions, how we can fight against this financial crime. So why are we talking about all these things, right? So we have to deal with diverse set of data when we are talking about anti-money laundering. So in today's enterprise world, we operate a mix of legacy applications combined with modern technologies. So just as goods and capitals flow freely across the borders, it is the responsibility of the financial institutions to ensure that the money flows in the right way without a glitch. That is very, very essential, right? So here, the organizations, the financial institutions deal with diverse data. It could be your financial transactions, customer profiles, or it could be the KYC data, even news feeds, right? There could be some news feeds, there was some issue they raised or standards that got published. So they'll have to keep track of all of these diverse data. And you have the high volume data, high velocity of data, coming from different data sets. All of these things have to be taken through a system. That system is like a legacy, traditional rule-based system. These rule-based systems actually had too many false alarms. These are false positive up to 95%. For example, if there is an enterprise which has the business sending alerts about the legitimate transactions, maybe report anything about 10,000 USD. If it's going to report about 10,000 USD, there could be hundreds of legitimate transactions happening in that month. If it ends up prompting and reporting for all that, and later the compliance personnel, the human who has to sit and review this, it takes a lot of time, a lot of energy, waste of resources, costing, all of that, right? So this slows down the real threat detection. So what do we need? We need real context-aware methods which can cut down the false alarms, increase the focus, and then helps us to detect the real risk quickly at a lower cost. That is what we need. Before we get into the actual solution and agentic AI implementation, I want to talk a little bit about the technology that is powering the implementation. So let me say something. All of us might have used talking to either Siri or your Alexa, a bank chatbot, something or the other, even in the middle of night. Many times, we would have felt that it is far more better and easier to talk to these bots than your close friend, or even for your spouse for the matter, right? So I see a lot of smiles. So this is the fact. So when you have a bot which is so powerful and responding, let's see what is the tech powering the bots. Imagine you have an agent which is so powerful, implemented for this. So what is this agent basically built out? We also had a lot of things that Dr. Swami covered as part of our morning agentic AI keynote about the agents and the latest launches. So when you talk about an agent in simple, you have a prompt which is sent to the agent. That is the question that you wanted to ask. Maybe you have diverse set of data coming in. You're defining an agent which is going to take the data, process it. So when the prompt is sent to the agent is capable of invoking any tool. It could be the code interpreter, or it could talk to your database, anything. It could invoke your tool. The tool will process the information and return the data to the agent. And the agent is also capable of invoking the LLMs. It could be Olama, GPT, anything. So this again fetches the results back to the agent. So both the results are available in the agent, and the agent is going to process that and create or curate in a human readable content, and it's going to pass it on to the user or the application from where this agent is being invoked. So that's the agent in a nutshell. So when we say agent, what is the difference between agentic AI and agentic AI workflow? Because the solution that we are going to implement for this is agentic AI workflow, right? So the agentic AI, it's basically an autonomous entity which makes decisions and act upon those decisions to accomplish a goal with minimal human intervention. And when you talk about agentic AI workflow, it's the coordinated sequence where the multiple agents are orchestrating to accomplish a complex goal to solve the biggest problem that you have. So this is what we talk about agentic AI and agentic AI workflow. And when do we use agentic AI workflow? Just because everywhere we talk about agents, not necessary that we have to use only agentic AI to every damn problem that we see. There are advantages in using traditional as well as agentic AI. So that's what I wanted to talk about in this. So when you take about agentic AI, when you want to deal with complex workflows, when you have a diverse data set, or when you wanted to have a memory that is to be retained after the conversations that is happening from start to end. So in all these cases, you will go for agentic AI workflow. When we talk about the tools that is powering this, you will understand and relate this better. But for now, so for all these scenarios, we'll go for agentic AI workflow. And for the traditional, when you have the mission critical applications where the results has to be 100% deterministic, we would go for this traditional workflow. And when you have a system which needs ultra low latency, you need this. And if it is a fixed rule based system which can actually derive better results with that, then traditional solution is better. Okay, so now when we talk about these things, what are the technology that is powering these solutions? So we're going to talk about AWS Strands SDK and Amazon Bedrock Agent Core, which has powered these things. So when you say Strands SDK, it's the open source framework from Amazon with which, without worrying too much about the infrastructure or writing thousands and thousands of lines of code, with just few lines, anybody should be able to create an agent. If you had watched the keynote today, so Swami gave an amazing number. There are already over 5 million downloads for this Strands SDK. People are really using like day in and day out. Anybody talking about agents are building agents with Strands SDK. It's becoming so powerful. So that's what we have used as well to create our agents. It can actually natively integrate with any of the AWS services, and it can connect to native tools, any MCP servers, whether you have created or it's external. It works seamlessly. It can work with any model. That is the power of Strands SDK. And so when you have one agent, you create it for one task, it's all good, right? Imagine you have a stream of agent interconnected to actually think, act, and remember all at once at a massive scale. That's when we need service like Bedrock Agent Core to take care of all of this completely. So you build agent with Strands SDK, or you can build agents with any framework for the matter. It could be from Llama Index, LangChain, LangGraph, CrewAI, or Google. So you build with anything. You can use Amazon Bedrock Agent Core to deploy. That is so powerful. It is not just a single service. It's a composite suite of services which helps you address whole lot of logistics that is involved in deploying an agent at a production scale. You imagine an agent when you wanted to deploy, you don't have to deal with infrastructure. That's where runtime comes into picture. And when you're deploying it, you have to ensure that the conversation between the agents are secured, seamless, and nothing gets leaked beyond the conversation context. So in this case, the identity management comes into picture. So when your agent wanted to interact with other tools and other stuff, Bedrock Agent Core Gateway is there. And when you wanted to audit, debug, and report, that's where Agent Core Observability is there. And so when you want these informations across the conversations and chats has to be remembered, referred for insights, that's when Agent Core Memory comes into picture. All of these components holistically work together to help you deploy agent run at a production scale. But otherwise, if you see, I have a friend who was actually saying, when you do a lot of POCs, agentic AI solutions, most of the POCs end by like death by POC. That's a term. It was used by one of my friends. So everybody starts with agentic AI, right? Where it suffers, where it struggles is for taking it to production is when struggles. That's where Agent Core is here to rescue and take care. Let's drill down and look into three major components. We can talk about Agent Core for hours together, but I want to drill down and talk about three important components here, which we are going to extensively use for the workflow that we have designed. So you take Agent Core Runtime. It is the completely managed serverless service but it's not like a traditional serverless service. We are just invoking a function, returning a result, and going to use it. This agent core runtime is a micro VM. Whenever you're hosting an agent, deploying an agent, this micro VM is started, and this micro VM is available and runs for the maximum up to 8 hours to serve the functionality of the agent to the invoked application. So that is how the micro VM is available, which is unlike the traditional system. And using this, you can actually deploy the agents created from any framework, as I mentioned earlier. It could be from your LangChain, LangGraph, Llama Index, or Crew AI. Irrespective of that, you'll be able to build. All that you needed is when you invoke this agent core runtime, it creates the Docker Compose file, and it deploys it to the ECS repository. Once it is, the image is made available in the ECR repository, it can be invoked and deployed into the runtime. Once it is deployed, you have an endpoint made available which can be used to integrate with the application to serve your customer request. So that's how this agent core runtime works in a nutshell. And when we talk about the agent core gateway, so you're creating one agent. This agent cannot work alone. It needs to interact with multiple agents, right? So when you wanted this agent to interact with multiple agents, for an example, we spoke about diverse data. When the diverse data are coming in, we have an agent which is going to read the data and see whether some data is actually false positive or not. So you need an agent. So this agent should also go and check the KYC data or the last 7 weeks, 7 days data to see what's there any risk. So when it has to do all of these things, it has to interact with different tools. One agent cannot do everything, right? It needs to have multiple agents or multiple tools. So you can use Agent Core Gateway to connect to the API gateway, and the API gateway in turn connect to different tools within AWS services. It can invoke and it processes and returns the information that is needed. We can also make this Agent Core Gateway connect to your Lambda function, which is going to again process a set of tools and return the results. It can talk to another set of MCP tools. So the inbound authentication stops at this Agent Core Gateway, and the Agent Core Gateway takes care of the rest of the interactions with the tools, MCP tools, or the AWS services like API endpoint or Lambda and the return results. So that's how Agent Core Gateway works. And the next one important thing is, okay, you have a runtime, you have hosted, you have a gateway which can help you interact. All is fine, but we need memory. Whatever conversation that happens, whatever the processing that happens, all that has to be recorded, stored for using it now, at least during the process, or later. So for that, the Agent Core memory has an amazing feature. Let's talk about two things: short-term memory and long-term memory, how it works. So when you take an agent, there is an agent implementation. When the agent is implemented, there will be a sequence of event happenings. When the sequence of events are happening, there are messages which gets exchanged and the state that needs to be stored. So these messages and states will be stored in a memory called short-term memory, and this short-term memory can be made available or stored maximum up to 365 days. Don't ask why 365 days. It's a number. It's nice to say 1 year, right? So it is configurable. You can say whether I need it for like 1 month or 365 days. But the maximum is 365 days for short-term memory. And in case of long-term memory, you have a module called Automatic Memory Extraction Module, which processes these data which gets stored in short-term memory asynchronously and extracts insights, summary information, or the semantic data, all of that, and stores in the long-term memory. On the other hand, the agentic implementation that has, whenever it needs any of these information, could be user preferences or the insights that you wanted to process, you can actually go ahead and invoke this information and then use it asynchronously. So that's how short-term and long-term memory are super beneficial for the agentic AI workflow implementation. So we saw what is the global impact of anti-money laundering, and we went through the diverse set of data that we have, how the false alarms gets raised, how the compliance have been evolving. And we also spoke about the tech that is powering this agentic AI solution, and our agentic AI workflow is implemented using Strands SDK and Amazon Agent Bedrock core. So with this insights, I would call upon my co-speaker Ayana J. Krishnan, AJ, to continue from here. Thank you so much.
Thanks, Bona. Okay. So we all love Strands, which is really flexible, and we also love the agent core. It's very modular, and we can deploy at a scale. And let's dive into the solution. How are we solving the anti-money laundering, leveraging the agentic workflow? So these are the agents we lined up, act as an individual persona. Each one has a different role to play in this workflow. Let's start with the first agent, perception agent. This naming convention speaks for it. When the transaction comes, it will understand what is this transaction, add additional perception to it, and then it will connect to the different data source based on your requirement, based on your enterprise. It will connect to the different data source and add to the context agent. And the data source can be varied, but the context, you need to have a streamline the information before sending to any kind of reasoning agent. So the context, whatever we are telling, it's all between the enterprise, okay? But when come to the enterprise, the real-time data matters a lot. That's where we are going to add the news agent into the mixture, which will connect to the real-time data source and add as to the reasoning agent. This is where the real powerful comes. The reasoning agent will leverage both the unstructured data as well as it use the existing context retrieved from your enterprise and make a reasoning and forward to the risk agent. The risk agent make a decision. It can connect to your enterprise existing risk ML models, as well as based on all the context we have retrieved from this workflow, it also give a context and make a risk. Then action agent comes. So all good. Currently, whatever the actions we are making, it's all highly manual. This action agent take out those major chunk of this action and automate it. Like it can do the straight-through processing if it all goes good. And after that, all the workflows are fine. When come to any financial institution or any enterprise we are building it, application we are building it, the audit play a pivotal role. And when come to the audit, all the agent make a decision, and we want to make sure every information will be triaged and logged. So when if anybody want to go and make a decision why the risk score was different, we have all the information from multiple agent went through, we have an audit. Then learning agent, this is one of my favorite agent. We need to keep the system more autonomous because we want to, whatever we observe, we want to add to the system as a feedback loop. So when it will be evolved over the period of time, then we need to create a final report. So if you find it suspicious, you need to create the suspicious activity report. We will create a report leveraging a LLM. This is a high level. We orchestrated the workflow. It's completely modular. We can plug into our enterprise need with a different agent. I want a little bit zoom down on the risk agent, which is very important. Okay, based on the risk agent, the action agent will be invoked. Okay, if the score is less than 30, okay, perfect. We can do the straight-through processing. The agent can do the straight-through processing. Then if there is the score is on 30 or to between 50, this will vary. We can make sure we are notifying it. Okay, and if it's a repeated pattern, we need to mandatorily file the report. The report we will be created using LLM, and we also make sure this transaction is monitored and flagged. But if we feel the score is high, currently, whatever the action we are making, sometimes most of the time we do the false positive. But with this kind of approach, we will be able to take a freeze that and make a next action. This is how the overall system we were orchestrated. Let me come into the technical deep dive of how we lined up this agent, how we use the strands and made it monodal. We made it as a layered approach based on the use case. We all started with the major chunk of use case in the AML, the transaction monitoring. And post created this workflow end-to-end and made it work. We plugged into the additional layer, which we added a more context by adding the real-time information like a news, OFAN, all those information. Now we have created a context, we have created an end-to-end workflow. We want to make it more autonomous. That's where the third layer comes. We added the learning agent, and we added a more audit into the picture, okay? So this is how we, step by step, we have built the agents. Let me dive into the transaction monitoring and spend some time on it. The real-time data we are processing using a Kinesis. Once we have a real-time data, based on that transaction information, we will connect to the existing data source. It can be your CRM, or think like we have everything in our RDS or a relational database. It'll go connect to it to get those KYC, and the perception agent, based on that, it'll create a triage of how this transaction looks like. We are using a Bedrock for different kind of model for different purpose. Now let me come to the next one, the context agent. With all the information we collected, we created the context agent, but the context agent had a very critical thing about the historical data. The historical data, currently we are keeping all the information in a DynamoDB for the faster retrieval, and we build a flurry of tools. Take a last in transaction, tell the so-and-so date transaction is a recently flagged. We created a multiple tools using a Lambda function, and we kept agent core gateway as a front end, and we connect from the context agent to those Lambda function to retrieve the data via gateway. So we no need to change the architecture. If you have an additional requirement to connect to the data, all you need to do is build an additional tool, and it will be more flexible. Based on your requirement, we can add it. Now we have created a context agent and connected to the historical data with the real-time data. Good. Now we are adding to the reasoning agent. All the context will be sent to the reasoning agent. It used the reasoning model to make a complete understanding. It created a risk score by itself based on how we prompted and orchestrated. With all the context, we got it from perception agent as well as the context agent. Once we have the complete details from the context agent, and the reasoning agent, we are taking into the action agent. We created a tools here also. We can build a multiple tools based on your requirement. At least for the transaction monitoring, the notification is very important. We created a tool for a notification, and also we want to make sure if it is high risk, we want to flag the transaction. So we have created the tool based on the information we got it from the context, we got it from the reasoning agent. We will be able to make action, and it create if we find it, yes, this is a transaction which we want to create the suspicious action report. Currently in industry, everything need to be done manually, and whatever the transaction they have seen, they have to create a manual report. With the proper prompt template structure, we will be able to pre-fill this one and store it into the S3. As I mentioned clearly, auditing is a very important task if you want to make a decision. That's where the audit agent will come into the picture. All the context we taken from the perception to all the layers, and whatever the action we take, we audit everything and keep it in an Elasticsearch. So think like it. If they found there is a suspicious in the transaction, it automatically created a report. If the human in the loop, they can check the report. At the same time, how we made a decision, everything will be in an Elasticsearch. So that is how we orchestrated this flow for the transaction monitoring. The next layer what we build is the adverse media monitoring, where we want to add the real-time information of the news. Okay, we added a news. We created a new agent, which is a new news herald agent. So that is how we modularly we make it very flexible, so we can keep adding our agent based on our use case. That with the power of Strands and Agent Core, we added the news herald agent, and whatever the information it is getting, it added to the memory. Why memory? Imagine if there is a new transaction coming and the same person is doing it. We want to make a quick action. So yesterday there is a news comes and we may be flagged, and if there is a change in news, it'll have both the context. There is a negative news, there is a positive news, this is a recent information. We can make a decision accordingly. Currently, whatever we are doing is we are doing it manually, but with the agent core memory, this will add a context in a real time what we are fetching from the news agent to make a decision. All this will be fed into the context agent. If you look at before, this will add your previous internal information to the context in a transaction monitoring. Here we are adding a real-time information to the context. So news is one factor, but when it comes to the anti-money laundering, it's very vast. Country to country, that it will be vary. The data source which each country or whatever the act they have will keep vary. Take an example of OFAN, Office of Foreign Asset Control, which they publish the report very frequently. It has all the information. If any political exposed person, something the sanctions are happening, every information will be here. This I'm taking an example. So based on your requirement, we can add to that particular data source. We use the Lambda, which will periodically retrieve the data, and of course we are using a Bedrock to do the embedding and write it to our knowledge base. Why knowledge base? When we want to, the news herald agent, whichever we built it, it have both the context of the real-time information, which we fetch from the news, as well as according to your country or act, it will have this information in a Bedrock knowledge base. Both the information will be fed into the context agent. Okay, so post the second, this is the final layer we have built. It's all more about instant risk introduction. Okay, the reason why we want to do this manner is currently mostly we are doing in a reactive fashion. Now also I'm saying it's not 100% we will be able to proactively do it, but we can make a quicker action and avoid more false positive in this approach. Here we added 2 more agents. One is on the risk assessor agent. What this risk assessor agent will do, right? So it will integrate it to your class internally. Currently, whatever the way we are doing, right? We may be using a classic model. It can be your classification model, or it can be your clustering model, the classic ML model you have. That is how we are flagging whether it is a risk or not. What we are doing is we are adding that as an additional context to the action agent. So whatever the information we got it, we are adding a new agent which will connect us to the API and get what is the risk score for this kind of transaction, and add this information to the action agent. And finally, we are adding the learning agent. Whatever information the risk was done, it will be taken into the account using the learning agent. It will take all the context information and write it back to the DynamoDB. Then it acts as a feedback loop for our transaction monitoring. This is how we have structured the agent. So it is highly modular. Every use case will differ, and every requirement may be differ. Based on your use case, you can think this as a reference, and you can build on top of it. What we have done on this workflow, what we learned on this workflow, right? We identified the classic ML way we are doing is really working well. But there is a challenge. We are not able to do proactive action, okay? Because lot of decision we are making, it's all in an unstructured manner. This agentic workflow, we added the classic ML feature into our agentic workflow pipeline, and we leverage the GenAI to process the unstructured data. And using a Bedrock, we applied all the guardrails needed to make sure that it is not hallucinating or it aligned to the enterprise need. what we have achieved via this anti-money laundering agentic system we built using Strands and agent core, right? I love the future of observability, agent core observability. All the information we have called, what tool we have called, and how much time the tool spent at time, how we made all the information. I no need to build anything. I take care of my audit trial, and what done at the transaction level, everything was observed by the observability. Then real-time injection, we have used a Kinesis, or we can use a Kafka according to our requirement. And session initialization, we are adding, the context is what the center of the piece, right? We are using a Bedrock knowledge base, we are using a agent core memory to manage the complete session, and semantic reasoning for that. So, and security and compliance, we want to store all the data into the S3, and it is encrypted, and we are using a Bedrock, connecting to the Bedrock model as well as agent core, using a VPC endpoint. Then all the transaction information, the lineage, everything we are using a Elasticsearch serverless, which is highly scalable for our requirement. Then our favorite, we are using different model for different requirement. We are using for the reasoning, we are using a Bedrock Cloud model. So under the Bedrock, we are using a Cloud model. For a different purpose, we are using a Nova model. So this is how we structured it. What is our expectation result? Yes, we reduced the manual review. As I mentioned, how the report was generated is manual. We are able to accelerate using our LLM to create those reports, and reducing the false positive and try to track it in a earlier manner. And audit trial, whatever the agentic workflow done, all the context, all the lineage information, we are able to track it down. That is the expected results from us. That's all from me. And this is me, AJ. I tried to hand over the demo, real-time demo, which will be done by Vivek, my fellow AI hero.
Thank you. So it's time for the demo. We have understood how things work and what we have achieved to do. So I'm going to concentrate on one of the most important agents in this whole workflow, which is the reasoning agent. So the reasoning agent is built using the Strands Agent SDK. And as you can see, the agent class is instantiated, which is from the Strands agents. And the name of that is reasoning agent. And the system prompt actually defines the behavior of the whole agent, which includes figuring out what the transaction does by creating hypotheses, indicators, explanation, confidence, and recommending what step needs to be taken next for this particular transaction that comes through. With that being said, it also understands that the reasoning agent depends on the output and the context that comes from the previous agents that is in the workflow. That is held using our agent core memory. This helps the reasoning agent to make very informed decision about how to navigate to make an informed decision about a particular transaction before marking that as a fraudulent transaction or not. So this agent core memory helps you to maintain the context across the whole session of the workflow by saving the outputs of each and every single agent that works in this particular workflow. And as you can see here, we are trying to keep the context from perception, context, and all the other agents, and all these outputs have been put under here. With that being said, this helps you to actually understand how we need to actually take a transaction, stream it through Kinesis, take it from Lambda, and also work through the entire agent core system and figure out how this transaction comes through. So this is a simple UI that we have built, and this is pre-loaded with a couple of scenarios that you can see on the right, on the left side. The scenarios are of different transactions of different types of categories, which includes low-risk transaction, medium risk, and high-risk transactions. And you can notice at the below that, you can notice how in the below that how this looks like, and we have both a PEP donation into microstate NGO. That is what we are going to pick as one of the first scenario that we wanted to run it through. And there are multiple orchestrations that we have already seen. We're going to pick the first one, which is your behavioral signal triage, and that has a 5-agent system, which is your perception, context, reasoning, action, and audit. we're going to run the system to see how this transaction is being dealt with this agentic workflow. So all these agents are being executed at the moment, and once the whole execution is done, we also know how it really works under the hood by interacting with the gateway and interacting with the agent core memory and all the other stuff. And the verdict that this agentic workflow gives for this scenario is that you need to file an SIR report and freeze this transaction. But we are really interested to understand that how this decision is really made by the agent, because we want to uncover this black box. So the perception agent tries to understand the users, which is the receiver and the sender, about what amount is being sent, what is the currency that is being there, and where is it being sent, and so on. And one of the most important jobs of the perception agent is to understand the KYC of both the sender and the receiver here. So it picks up the KYC details of the sender and the receiver, and as you can see, the sender is also marked as a high-risk entity, and the receiver KYC also have been marked as one of the high-risk entity that we have in the system. So these are some of the important features that the perception agent picks up, and not just that, the perception agent also calculates a couple of other features, such as what is the device is being used, and what is the deviation of amount that takes place in the transaction, and so on. And with all this information, that is being stored in agent core memory, and that is passed down to your next agent, which is your context agent. The context agent picks up the details of the sender and the receiver of the 60-day transaction that it takes place. So it calculates a lot of behavioral features from out of it, like what's the rolling average and so on. And now comes one of the most important and the core agent of the whole workflow, which is your reasoning agent. So the reasoning agent comes with three different things, which is it creates a hypothesis first, like to understand what to really make out of this transaction. So the hypothesis that it really makes out is that the transaction may be suspicious, but involvement of a PEP and an excluded provider, and it creates an indicators how it really marks that why it makes this transaction a little bit risky, and it gives a detailed explanation what really it understands from the transaction. And the decision made is around 0.85 of confidence, and it recommends the steps as well. And that is passed down to your action agent, which recommends that this needs to be filed a SIR report, and you need to freeze this transaction. And a lot of other actions have been executed along the same, which is like you have to freeze the transaction, notify the operations team, and you have to also store the SIR report. But depending on your organization, you can also execute a lot of other tools and workflows underneath. And the audit trail is one of the important agent in the system, which understands and picks up all the necessary outputs and details that has been generated by each and every single agent in the system, which basically keeps your audit clean and ready. And with that being said, the output is we have to file an SIR, and this is the SIR report it has been generated. And the audit trail actually gives a detailed information about each and every single agent that is being executed, and what information it has collected, and what information it has produced, and so on, so that a human in this particular loop can identify and figure out how it's been really the decision is made. Now let's try to run the same scenario using our next use case, which is a reputation pulse scan. And you can notice that we are going to include a new agent in this workflow, which is your news agent. Let's run this orchestration and see how that works out. And it goes through each and every agent, and it tries to understand how the transaction works. And with that being said, once the transaction is completed, you get to see the entire results of how this agent has taken this particular verdict. So we already know how the other agents work. Let's jump into how this news agent is really working out in this new use case. So it tries to understand what is a sender country, receiver country, and so on. And one of the notes it has really maintained is that the receiver is a sanctioned person. So let's go into audit to really figure out how the news agent really came up with this particular results. So you can see here that in the news, it has mentioned that the receiver is sanctioned, but also this news agent just not stops there. It tries to understand who's the receiver, who's the sender, by going and interacting with the sanctions list that is available to mark if the person is under the sanctions list, and also checks the geopolitical situation of the transaction to see if some transaction needs to be restricted based on the country of the sender and receiver. And the third orchestration workflow is that you have all the agents in the workflow, which is your complex and the full use case that we see, and it involves both risk and the learning agent. So let's try to see how this orchestration goes through, and our going to be our focus is about to learn about how this risk agent comes into the whole picture and how does it really influence the whole decision making process, and how this learning agent is going to keep us involved in this whole process about to figure out how these patterns are not being repeated in the future. So once this agent has been executed, let's jump into what we are really interested about, which is your risk agent. So we have mocked a rule engine system in this whole workflow, and this rule engine could be your organization's rule engine or maybe the compliance's rule engine that you might have. All right. So the rule engine that we have created is that the agent has figured out that there's a high risk of entity rating for the sender, and there is a sanctioned status of the receiver. Let's go into this audit report and see how this agent really worked out and what are the information it was able to figure out from this whole thing. So you can see here that these are the rules that this particular agent was able to pick up and execute based on how it really worked. So this agent is not particularly an LLM focused agent. It's a Python agent, but it's driven by your classical machine learning model or your rule engine. Based on all these rule engines which has been created, these are the contributing factors it has figured out that it might influence the transaction status and what needs to be done with the transaction here. And with that being said, the learning agent tries to picks up all these learnings, put backs into the DynamoDB that we already have, so that when the next such patterns occurs, your agents are much more intelligent enough to go ahead and make more informed decisions around it. So now that we have seen a scenario with almost all the 3 different use cases, let's try to mix and match different scenarios and see how that really helps out for us. So we are going to run the L3 use case with the second scenario, which is we're going to execute a payroll, which is from a Singapore public official. The verdict is that, you need to file an SIR, but this transaction is okay to be let out, but you need to keep monitoring to see if something really flags out in the future. So you can see that who's the sender and the receiver of the agent. The reasoning agent picks out that this is a payroll payment and so on. And this is the verdict that it comes out with. Now, let's even more go with a very simple low-risk entity scenario, and let's run with one of the most simplest agentic workflow that we have here. With that being said, we are going to run a scenario which is a synthetic community payroll. Though this is a very low-risk entity, this still flags out that you need to file an SIR, which is your suspicious activity report, and you have to monitor the transaction over here. And if you go into the audit report, it figures out and shows you the whole detail about what really made this decision needs to be made. So with that all being said, we have seen scenarios where how a transaction is being taken and how it's being sent into Kinesis, and how this whole agentic workflows has been deployed in agent code runtime, which makes it super easy. And with the help of gateway to access the more tools outside the agent to give the agents much more accessibility, and also the memory to keep a context of every single transaction that comes from the perception to the end of the agents to figure out to make a more informed decisions around it. So we have used a couple of strategies to keep the memories much more consistent. So we have used short-term memory, but we have manually written down each and every output of the agents which goes there. So this is a complete demo that goes into, but let's take a bit of time to understand how this couple of other agents has been written, because not every single agent that we have seen is not a Strands agent in particular. So let me go to one of the agents that we have, which is your So let's start with the perception agent, which is our most familiar agent that we have. So here the perception agent is not really your an LLM powered agent, but it is a Python powered agent, but it still utilizes the tools which is being exposed to this in a way that it was able to access the information about your KYC details and much more. And we have the context agent, which tries to retrieve the same about the 60 days transaction details of the both the receiver and the sender, and even that is exposed to you by from DynamoDB through a gateway tools that is being through agent code gateway tools. And we all know the most important agent is a reasoning agent, which we already seen at the start of the demo. And this also ensures that it drops down the whole information about how the decision is being made and how it is being made as well. And the reasoning agent has a couple of entities like the indicator, what hypothesis it has made, and what explanation it has given. And also the most important thing is how confident it is with the score that has been generated, so that this transaction could be flagged or not. And next we have is our, before that we also have a news agent. So news agent is something which we have actually taken a special interest to create it. Usually this news agent would be a couple of APIs which gives you information about the SDN reports or the securities reports or the sanctions list and so on. But for the simplicity of this particular demo, we have stored the entire sanctions and the securities list in a knowledge base, and we have exposed this knowledge base to the agent so that it can access to figure out whether this receiver or sender is part of this particular sanctions list and so on. And most importantly, not everything could be just covered by saying that it is, if it's just from the sanctions list, it is meant to be a fraudulent transaction. It's not necessarily need to be. So we also actively monitor what is a geopolitical situation that occurs around the transaction. Like, for example, there is a war-stricken country and it's trying to transact an amount which is very high. Of course, the human who is in the system would be able to easily understand that, hey, there is something wrong which is going on. But your agent might really pass it out because that's not really that flagged out as a suspicious transaction. But the news agent, which has access to the internet through the tool of using the browser, it's able to understand that, hey, there is a war-stricken country and this is trying to make a transaction. And with all this information about this news, the KYC details and the history of the transaction, your reasoning agent now has more information and as much efficiency as a human to make more informed decision that this transaction might be flagged as a money laundering transaction with being over here. And the rest of the agents keeps the actions being executed. So the action agent figures out which sort of risk band that it falls through, and we have your risk agent, which actually combines your existing machine learning models or the classical models that you might build for your company or your organization, so that you don't leave out the legacy system out of the picture, but you also use them as one of your helping hands to make much more informed decisions. This also helps you to keep the compliances much more intact with the new solutions and keeping the old legacy solution into the system. And all that being said, the audit helps you to keep the entire trail of the transactions, and that helps you to keep your compliance team much more happy to understand how this agent is making much more informed decisions. And we have finally the learning agent, where it gives you the feedback loop of how this transaction has been evaluated, and what was the risk which was associated, and what was the reasons it has been made, and how this entity's risk band has been updated post this evaluation. And this learning agent keeps updating the databases, which helps you to make much more informed decisions of such existing patterns occurring in the future as well. So with that being said, this completely helps you to understand how we have built an entire workflow to understand how to flag out transaction which might be a money laundering fraudulent transactions here. And the multi-agent orchestration systems have been really helpful to increase the accuracy and decrease the time in flagging out the system and improving the efficiency of the whole organization as well. So this is Vivek Raja. I'm AWS Machine Learning Hero, and along with me is Bhuvaneshwari Subramani, who is AWS Hero, and we have Ayana J. Krishnan, who is representing AWS community, and he is also Machine Learning Hero. We'll be around in this hallway if you have doubts or you wanted to interact more about how this solution works. Sorry? Okay. So this is us, and we'll be available in the hallway if you wanted to catch up with us to understand more about how the solution works, or how you wanted to integrate these with your existing solutions that you have in your company, or you wanted to explore the same. So thank you everyone for this.